Hello everyone, this is Ashita. We are group 6 and our group activities on linear regression. So let's begin. This is a presentation outline. It consists of introduction, problem statement, objectives, a detailed description on linear regression, proposed data set, results, and conclusion. Coming to introduction, earlier companies manufacturers they manufactured products which were considered in demand, and this may lead to financial loss. Sales prediction is needed to optimize inventory, allocate resources, and to improve market strategies. Computer systems can aid sales predictions by modeling professional manager skills or utilizing machine learning to analyze data set and improve forecasts. Companies use various machine learning methods like time series, analysis, regression, decision trees, classification, clustering, neural networks, and random forests to predict future sales. A common method for sales prediction, that is linear regression, uses historical data to train models that predict future sales by combining independent variables to forecast the dependent variables. This is our problem statement. Our problem statement is to give a brief report on linear regression, compute the statistical methods, implement a simple linear regression model, and draw the scatter plot for online product price. Coming to objectives, the objectives of this project is to collect the dataset from Kaggle and analyze it, to develop our own dataset for the purpose of product cost prediction, to calculate statistical operations, mean, median, variance, and standard deviations, and to apply the linear regression algorithm and analyze model performance. Finally, our objective is to plot the graph and visualize the result, making use of data science.
Let us know some basics about the linear regression. Linear regression analysis is used to predict the value of a variable based on the value of another variable. The variable you want to predict called as a dependent variable, and the variable you are using to predict the another variable is known as an independent variable. The equation for the linear regression is y equals to mx plus b, where the y is represent the dependent variable which is dependent on y, x is represent independent variable, b is the intercept, and m is the slope of a line. And the user can perform a linear regression. User can perform the linear regression in the various programs that are R2 linear regression, MATLAB linear regression, SQL linear regression, and linear regression Python. And we can create the linear regression model by fitting the line among various scattered plots, scattered data points. Linear regression can be used in the business to evaluate the trends and make estimate of the forecast. For example, if the companies are increased steadily in every month, by conducting the linear analysis on the sales data with the monthly sales, the company could forecast the sales in the future months. Why we selected the linear regression in the various machine learning technique? Because linear regression models are relatively simple model, provide an easy to interpret the mathematical formula that can generate the prediction. And linear regression can be applied to various areas in business and academics. Linear regression is used in everything from biological, behavioral, environmental, and social science to business. Linear regression is a long established statistical procedure. The properties of a linear regression models are well understood and can be trained very well quickly.
This is our proposed data set, which consists of brand name, sales percentage, price, and date as attributes. After analyzing the online dataset, we have proposed our own dataset called product dataset. It consists of 4 attributes named as brand name, sales percentage, price, and date. In these four attributes, most dependable is sales percentage and price because it indicates the straightforward discount and find attractive and easy to understand. It is crucial factor influencing purchase decision. Least least dependable is date because it may be less critical for some product and timeless design also matters. Overall, the dependability of these attributes can be vary. Overall, the dependability of these attributes can be very based on consumer perception and individual preferences. These are the results that we have conducted. DF is equal to PD dot read CSV product dataset dot CSV is to read the product dataset, and this is the five. This is a printout of the first five rows or columns of the dataset. Mean calculation is stored in mean price. Median calculation is stored in median price. Variance is stored in variance price, and standard deviation of the pricing is stored in standard deviation price. These all are printed using the print statement. This is the output of mean, median, variance, and standard deviation of the price calculation. Plotting the scatter plot. Plot dot figure. It consists of 10 and 6. Scatter plot, X is labeled as sales percentage, Y is labeled as price, and from data frame you have extracted the data. And the title of the plot is sales percentage versus price scatter plot. Plot dot show is used to show the scatter plot.
The sales percentage attribute of data frame is stored in X and the price is stored in Y, and X train, X test and X train Y test is splitted with the size of 0.2 with random state 42, and the model is called as a linear regression, and model is fitted X train and Y train. Here the model is generated, and next is Y predicted value from the model is given as an array. Mean square error is calculated for Y test and Y predicted value, where that result is stored in R2, and next is print the mean square error and the result that is stored in R2. Next is a figure, plotting the figure with SNS library, Seaborn library as SNS, and here X is labeled as X is percentage and Y is price, and the new data frame is stored in new data is stored in data frame and labeled as actual data. Next, and here it also has the regression line plot where it is colored with red and line width is 2. Next, the plot is titled as sale percentage versus price with regression line. And next, here legends are used because to differentiate the scatter plot and line plot. And this is a sales percentage versus price with linear regression plot, where it has a line plot and scatter plot. Here, blue dots are actual data, and red lines are regression lines.
In the conclusion, we have successfully collected the pre-processing data and creating relevant features that significantly impact product cost prediction. The linear regression model provides a fundamental understanding of factors influencing online product sales. Continuous refinement in incorporation of additional data sources can further enhance its predictive power and utility in marketing making informed business decisions. So, the linear regression model has provided the meaningful approximation of the relationship between dependent variable and the independent variables. So, product sales prediction is a vital tool for business, enabling them to operate more efficiently, make informed decisions, and utility enhance profitably and customer satisfaction. Thank you.
Here we import pandas, numpy, matplotlib for the this program, and import seaborn from scale and linear model. We import linear regression, and the train and test we used for the splitting of the data set, and we from skyline matrices we import mean square error R to score. So here we run. So here we run the program. So next we how to upload the files. We use from Google Colab import files. Uploaded is equal to files dot upload. Here from we uploaded the files, and here uploaded file is shown in this way. And here we use this statement for read the file, that product data set. Uh, Here the data set is displayed using this read functions, and and then we use this df.head to display the first 5 data set. Then we will show the mean price, median price, and variance and standard deviation price for the next to display the we use print of mean, median, variance, and standard deviation. Here the printed values will shown as we as shown in this. Here, the next we use scatter plot of plotting. Here, the figure to use this 6 comma 10 comma 6, and here label as sales percentage price and sales percentage versus price scatter plot. And this is plt dot show is shows the graph of this scatter plots, but that is sales percentage versus price.
Next, in this statement, the column sales percentage from the data frame is stored in the variable X and it is used as a feature. And the column price from the data frame is stored in the variable Y and it is used as a variable. And the next statement is used to split the model into training data set and the testing data set. Here, X-train and Y-train are used to train the data set, and X-test and Y-test are used to test the performance of the model. And 20% of the data is used to test the model, and remaining 80% of the data is used to train the model. And in the next step, in the next statement, model is equal to linear regression of it is used to create a linear regression, and it is stored in the variable model. And in the next step, we are used to calculate X-train and Y-train training. We are training the models. And in the next step, we are predicting the tested variables. And this step is used to print the tested prediction values. And in the next step, mean squared error, we are calculating the mean squared error. It takes the 2 arguments, Y-test and Y-predictions, and it is stored in the variable MSE. And in the next step, we are calculating the R-square score. It takes the 2 arguments, Y-test and Y-prediction, and it is stored in the variable R-square. And these 2 print statements are used to print the mean squared error and R-square score. In this step, we are displaying the mean squared error and R-square test. And this code is used to plot the
figure. Plot figure, we are creating a figure of width 10 and height 6. And this statement is used to create the scatter plot, and we are giving the x-axis as a name, sales percentage, and y as a price. And we are labeling it as a actual data. And we are giving the title for the scatter plot as sales percentage versus price with regression line. And we are labeling it as sales percent. And we are labeling x as sales percentage and y as price. And plot.descent is used to differentiate the actual data points versus linear regression. And plt.show is used to display the figure. This is the output we got. Thank you.